Hello everyone, welcome back to Math with Amala. Let's move to grade 9 chapter 1 part 5. We have discussed about irrational numbers in the previous part. We could see that Pythagoras was trying to prove the value of root 2 through his theorem, Pythagoras theorem. Here we have two mathematicians, Cantor and Dedekind, who were making a correspondence between the real numbers and the number line or points on the number line. So according to them, corresponding to every real number, there is a point on the real number line. Actually, this is true as we have discussed in the previous class. If we take any real number, you can find a particular point on the number line. Even if it is a rational, an irrational, a whole number, whatever be the number with point or continuous, whatever be the number, even if it is recurring or non-recurring, you can find it on the real number line. So it's vice versa is also true. That means if you take any point from the real number line, you can find a particular point or particular number, a particular real number corresponding to that number line point. Let's move to an example. Example number 3. Locate root 2 on the number line. We know that root 2 is a real number. So we have to show that it should be, it is having a point on the number line. For that, we have to construct a square of side 1 centimeter or 1 unit, whatever it may be, like the Pythagoras have constructed to prove the root 2 value. Consider the diagonal of the square OB, or we can say the hypotenuse of the right angle triangle OAB. We know this method from the Pythagoras theorem. Now let's see how we can represent this number root 2 on the number line. Okay, so in the number line you can have 0, 1, 2, 3, etc. Since root 2 is lying in between root 1 and root 4. What is the reason? Between root 1 and root 4 means it is lying in between 1 and 2 only. Okay, so in between 1 and 2 you can give the value root 2. For that, let's take OB equal to root 2 and take a compass and mark the center as O. Okay, center as O, and you can take your compass with its nib on the O and OB as the radius. Now you can draw this on the number line. So the radius is root 2. You can draw an arc. No need of drawing the complete circle. You can just draw the arc and let it touch at the number line. Now you will get a point on the number line on the x-axis or the number line, which will be equal to the value of root 2. Okay, what is the reason? If we draw the arc, the radius will be same always from the center O. Okay, so this OB will be same as the point on the number line. Now let's move to the next example, which is example number 4, not 3. 3 we have already discussed. So the example number 4 is to locate root 3 on the number line. We have represented root 2 on the number line with the arc. We can use the same method to represent root 3 also. So where is root 3? Root 3 can be found through the same method as we have found for the root 2. We can use the right angle triangle or the square method. Let's draw the right angle first. Then draw 1 unit perpendicular line at the root 2 hypotenuse. And you will get that root 2 the whole square plus 1 square is equal to 2 plus 1, that is 3. Which means its root is, that hypotenuse will be root 3. So OD we can be calculated to root 3. Now let's take OD as the radius. Now let's take O as center, OD as the radius, and you can extend the baseline O towards the right, and you can make an arc which is intersecting at the baseline, which is the number line. Now you will get that this value also will be in between 1 and. Thank you all for watching the video. Please be stay tuned for the next part, which contains more number line representations.